In this video, we'll discuss about add two numbers. So first, let's understand the question. You are given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order and each of their nodes contains a single digit. Add the two numbers and return the sum as a linked list. You may assume the two numbers do not contain any leading zero except the number 0 itself. So what they are trying to say is that you are given two linked lists as an input in which there are two integers which are stored in reversed order. Meaning this was integer 3, 4, 2 which was stored in reversed order in your linked list 2, 4, and 3, right? And this would have been 4, 6, 5, right? Now, every linked list node will always contain a single digit. These two integers will always be positive, and there won't be any leading zeros except when the integer itself is a 0. So, these are the assumptions. Now, what you need to do is that you need to do the sum of these two integers, and whatever is the sum has to be returned as a linked list, right? So now if you see here, if we add these two integers, then how do we add two numbers? We always start with the last digit of our numbers, right? And we add them. So in this case, 2 plus 5 is 7, right? And whenever we add these digits, we also see whether do we have a carry or not for the next set of digits. So in this case, 5 plus 2 was 7. So we didn't have any carry. So we'll move on to the next set of digits. So here we have 4 plus 6. Now 4 plus 6 gives us 10, right? Now in this case, we don't simply write 10. We keep this digit here, right? The last digit, which is 0. So 0 will be kept here, and whatever is this digit, 1, that is taken on as a carry to the next set of digits. So 1 will come here, right? Now here what we do is, we do 3 plus 4, and in addition to that, we also add this carry, right? So here 3 plus 4 will be 7, and 7 plus 1 will be 8, right? So the sum of these two integers is 807. Now this has to be returned as a linked list. Now these two integers were present in reversed order in our linked list. So this also has to be returned in reversed order. So your answer will be 708, right? This is what you need to return. But here we are given linked list, not these integers, right? So how are we going to approach this problem? So if you closely look that whenever we add two integers, we always start with the last digits, right? And we do their sum. And whatever is their sum, we write it here. And if in case we have any carry for the next set of digits, then we track that as well. Then when we come to the second last digits, right? And we add them, and we also add the carry in case if it is not 0, right? And we keep on doing this until the digits from both the integers get finished, right? So we are starting with the last digit, and since in our linked list, these integers are stored in reversed order. So whatever are your last digit of the two integers, that will be the first node in our linked list, right? Whatever are the second last digits of your integers, that will be the second node in our linked list. Whatever is the third last digit in your integer will be the third node in our linked list, and so on, right? So since while doing summation, we start with the last set of digits, then here we can start with the first node of our linked list, and then we can keep on adding the values of the two nodes, and we'll get our corresponding node, right? So here in the question, we are given a pointer to the head of the two linked lists, which is L1 and L2. Okay, I'll just write it here for future reference. So we are given two pointers, L1 and L2, which are pointing to the head of our linked list. So at every point, what you need to do is you consider this, and you add them, right? So what is the sum of 2 plus 5? That is 7. So a new node is created with the value as 7. Now in this case, there is no carry. Carry is 0. Then we move on to the next set of nodes. Then we do 4 plus 6. Now in this case, 4 plus 6 will be 10. And as I told you, in this case, whatever is the last digit, that we write here, and this digit is taken on as a carry. So in this case, here we will write 0. Here we'll create a new node with the value as 0, and this 1 will be taken on as a carry for these set of nodes, right? So now this will be 1 plus 3 plus 4. So this will be 8. So this will give me 8. So this is how I will create a linked list, which will be the sum of these two numbers, right? So now what you will do is, so first of all, we'll create a dummy node, okay? First of all, we'll create a dummy node. Let's suppose this value is 0. Anything you can give. Now, this node will help us return the head of our new linked list. See, when we are going to create our new linked list, so it will be like we created this node, then we'll created this node, then we created this node. So at every point we are moving to the next node. So at the last, you will have a reference to the last node, right? But in your answer, you need to return the head of your new linked list. So you need some pointer which points to the first node in your linked list. So this dummy node will help us return the head of our linked list. Okay, you will understand it more when we'll move forward. So first of all, we created a dummy node. So what we'll do? We'll do list node dummy equals to new list node, right? And we can give it any value. Let's suppose 0. Now we'll create a temporary pointer. See, I said whenever we create new nodes, we'll keep on moving forward. We'll keep on moving forward, right? So the pointer that we will keep on moving forward will be this temporary pointer that I'll create now, and this dummy pointer, whatever it is, that will remain as is. Okay. So we'll create another pointer that will be list node temp, right? Which will initially point to dummy, right? So this is pointing to dummy as of now. Okay. Now at every point we need to track the carry also, right? So we'll create a carry variable also whose initial value is 0. Now we will start iterating in our linked lists. So we'll iterate in our linked list. This condition we'll see what we are going to keep. As we keep on moving forward, we will identify what all conditions should be present in this while loop. So when you have started your looping and you have come across your first set of nodes, what you need to do? You need to perform their summation, right? So we'll create a sum variable whose initial value will be 0. Now you have to add these two. Now, if you closely look here, in the question, it is not given to us that the number of digits in the integers will always be the same. That means the number of nodes in our linked list will not always be the same. Let's suppose my number is 23, the first integer, and the second integer is 2. Then in that case, your first linked list will be this and second linked list will be this. So for these two nodes, you will be able to do the summation. This you will create 4. But for this node, you won't have a corresponding node in the next linked list, right? So in this case, you will simply do 3 here. This won't be considered, right? So there might be a case when a node is present in one of the linked list, but corresponding node is not present in the other linked list. So whenever we are performing the sum of our nodes values, then first we need to check that do we have a node available or not, right? So after creating this sum, we will check that if our L1 is not equals to null, right? If it is not null, then that means node is present. So in the sum, we will add L1's value, right? And for the next iteration, now we need to move to this node. So we will do L1 equals L1's next, right? So now this L1 will come here, right? Then similarly, we will do for the second linked list node. So if L2 is not equals to null, right? Then in the sum, we will add L2's value and we will move L2 forward, right? So then L1 is pointing here and now L2 will also point here, right? Now, at this point, you must have added L1's value in sum, which was 2. So at this point, sum was 2. Then at this point, you added L2's value, which was 5. So 2 plus 5 would be 7. So till now, the value of sum is 7. Now, we need to keep the track of carry also, right? And whenever the carry is not 0, we need to add it in our sum. So we'll do sum plus equals to carry. We'll add the carry also in our sum. Now, when you have calculated the sum, you need to change the carry. You need to update carry for the next set of digits, right? So let's suppose when you performed this much operation, the value of sum came out to be 10. So right now you will write 0 and 1 will be taken on as a carry. So you need to update carry here. Now how can we get the value this? How can we get this digit 1? If we divide it by 10, what will get? 1. So if we divide it by 10, we'll always get this digit. So what we'll do, carry will be equals to sum divided by 10. So in this case, our sum was 7. Till now, our sum was 7 and initially the value of carry is also 0. So at this point also the sum is 7. So now when you will update the carry for the next set of digits, it will be 7 divided by 10, which will be equals to 0. That means no carry for the next set of digits, right? Now, next what we'll do is we'll create a new node. We'll create a new linked list node, which will be the sums value. So new node equals to new list node And what will be its value? Now I said, let's suppose my sum is 10. So I will write only this digit, the last digit. So I'll do its modulus with 10. When you will do its modulus with 10, you will get the last digit always, right? So we will write here sum modulo 10. So in this case, our sum was 7. So 7 modulo 10 will be 7. So a new linked list node will be created whose value will be 7, right? So this will be our new node, right? Now what we'll do is we'll update temp. In the temps next, we will keep new node, right? So now our temp was this node, and in its next we are keeping the new node. So now this will point to this, okay? And then we'll move temp forward. So temp will be equals to temps next, right? So now temp will point to this node, okay? Now this is what we are going to do in our loop, right? Now till when are you going to perform all this? Whenever we are having any node in either of the linked list, till then obviously we are going to perform the summation, right? So two conditions will be while L1 is not equals to null or L2 is not equals to null, right? But we need to add one more condition here. And what is that condition? Now let us suppose that these were your last nodes, right? Now here actually the sum was coming at 8, but let's suppose the sum was 10, right? In that case, you would have written 0 here. But this one would be left because there are no nodes forward. Both our linked lists are completed, right? So this one would remain. You need to create one more node here whose value will be 1, right? So that case also you need to handle. So if in any case my carry is also present, that means my carry is not equals to 0, then in that case also I will come inside here. So in that case, what you will see that the sum is 0. My L1 is null, so it won't go inside this. L2 is null, it won't go inside this. Then whatever is my carry will become my sum because sum is initially 0. So whatever is the carry will become the sum and carry will be updated. A new node will be created with this sum and that will be added to my linked list. And after that, our carry will be updated to 0. So now this condition will also become false. So these three conditions we will add in our for loop, right? So now for our next iteration, our L1 and L2 are pointing to this. So now is L1 not equals to null? Yes. So we'll come inside this. Our sum is 0. L2 is not equals to null. So we'll come inside. What is L1's value? That is 4. So sum's value will be 4, right? And then L1 will move to the next node. So L1 will come here. Then L2 is not equals to null. So we will add L2's value also. So here the sum's value was 4. Here we'll add 6. So sum's value will become 10. And L2 will move on to the next node. So now L2 will come here. Now we'll do sum plus equals to carry. So carry's value was 0 from the previous iteration. So sum's value is 10. Then we'll update the carry. So carry will be 10 divided by 10, which is 1. So for the next set of digits, our carry is 1. Then we'll create a new node with the value what? Sum is 10. 10 modulo 10 will be 0. So with the value 0. So we'll create a new node here and its value will be 0. Now next is in the temps next, we will give this new node. So this 7 was our temp. So now this will point to the new node. This will happen. And then we'll move temp forward. So now temp will point to this, right? Now we come to the next iteration. Now L1 is pointing to this, L2 is pointing to this. So this condition is true. We'll come inside. Sum is 0. L1 is not equals to null. In sum, we'll add L1's value, which is 3. So sum will become 3. L1 now will move on to the next node. Now here we do not have a next node. So now our L1 will be equals to null, right? Then next L2 is not equals to null. In sum, we will add L2's value. So at this point it was 3. So here it will become 3 plus 4, which is 7. And then L2 will move forward. So now L2 will also be equals to null, right? Then we'll do sum plus equals to carry. Now from the previous set of digits, our carry was 1. And at this point, sum was 7. So it will be 7 plus 1 equals to 8, right? Then we'll update the carry, which will be 8 divided by 10, which is 0. So carry will be 0. And then we'll create a new list node. So our sum was 8. 8 modulo 10 will be 8, right? So we will create a new node and its value will be 8, right? Then in the temps next, we will give new node. So now this will point to this and then we'll move the temp forward. So now our temp will point to this node, right? Now our L1 is equals to null, so this condition is false. L2 is also equals to null, this condition is also false. And our carry is also 0. So this condition is also false. So this will be completed. Now you have created this linked list. And what you need to return? You need to return this much linked list, right? And Right now, my dummy is pointing to this node and my temp is pointing to this node. So how can I return this node? Dummies next, right? In dummies next, I have the head of my linked list. So what I will do, I will return dummies next here. Okay. So we will return this and this will be our answer. So I hope you got it. So now let's code it out. So first of all, we'll create a dummy node. So list node dummy equals to new list node whose value can be anything. Then we'll create another list node. We'll create a pointer temp which will point to dummy. Then we'll create a carry variable whose value will be 0 initially. And then we'll loop inside our linked list. So while L1 is not equals to null or L2 is not equals to null or carry is not equals to 0, right? Then what we'll do, we'll create a sum variable, right? Now we'll check that if L1 is not equals to null, then in the sum, we will add L1's value, right? And then we'll move L1 forward. Then we'll check for next node. If L2 is not equals to null, then in the sum, we'll add L2's value. And then we will move L2 forward. So L2 equals to L2's next. Then we'll add the carry also in our sum, right? Then we'll update the carry, which will be sum divided by 10, right? Then we'll create a new list node with our new value. So it will be new node equals to new list node and its value will be sum modulo 10, right? Then we will put the new node in temps next. So temps next equals to new node and then we will move temp forward. So temp equals to temps next and at the end I'll take the dummies next in the, let's suppose, head variable. So head equals to dummies next and now this dummy node is not needed, right? So we can delete it. There's no need of this dummy node and then we can return our head, right? So now let's run this. So in this case, if you will see now, we traversed only once in our entire linked list. So in this case, our time complexity will also be order of n, right? Where n will be the size of the longer linked list, right? So now let's submit this. So it got accepted. Thank you so much for watching.